Imagine a vast, cold void where time stretches beyond comprehension. In this frozen expanse, a comet drifts silently, carrying secrets from the birth of the universe. What if the key to alien life isn't buried beneath the surface of distant worlds, but hidden within the icy hearts of these wandering cosmic bodies? The universe is filled with comets, each one a time capsule from the earliest days of planetary formation. Some originate from the distant reaches of our own solar system, while others come from far beyond, born in the depths of interstellar space. Among these cosmic wanderers, two stand out: 3I Atlas and C2025 R2. Their journeys offer a rare opportunity to glimpse the chemistry of alien worlds, revealing clues about the origins of life and the fundamental building blocks of existence. Comets have always fascinated scientists and dreamers alike. They are remnants from the early solar system, formed in the cold outer regions where ice and rock coalesced under the influence of gravity. Most comets remain trapped in the Kuiper belt, or the distant Oort cloud, only occasionally nudged into paths that bring them toward the sun. When they do, the heat of the solar wind triggers a dramatic transformation. Volatile ices sublimate, releasing gases and dust that form the comet's glowing coma and sweeping tail. This process not only creates the breathtaking spectacle of a comet streaking across the night sky, but also offers a glimpse into the primordial materials that shaped the planets. However, some comets are not native to our solar system. Interstellar comets, such as 3I Atlas, arrive from the distant stars, their trajectories shaped by the gravitational forces of other planetary systems. These visitors carry with them the chemical signatures of their home worlds, offering an unprecedented chance to study the composition of alien environments. 3I Atlas, in particular, is a remarkable discovery. It is the third interstellar object ever identified, following the mysterious 1I Oumuamua and 2I Borisov. Unlike its predecessors, 3I Atlas exhibits clear signs of cometary activity, with a coma and tail forming as it approaches the sun. Its unusual chemical composition, including traces of cyanide and nickel, raises intriguing questions about the conditions in its place of origin. If this comet carries the remnants of a foreign star system, what secrets does it hold about the chemistry of alien worlds? Meanwhile, C2025 R2 presents a different kind of cosmic enigma, discovered by the Solar and Heliospheric Observatory's SWAN instrument. This comet has captured the attention of astronomers due to its sudden and dramatic brightening. Initially thought to be a typical solar system comet, its rapid evolution has hinted at something more extraordinary. The comet's dust storm, a swirling maelstrom of fine particles, suggests a violent internal disruption, possibly triggered by the sun's intense heat. Such events are rare and offer a unique window into the fragile nature of comets and the processes that govern their transformation. The presence of dust in its coma also raises questions about the role of comets in seeding the cosmos with organic material, potentially influencing the development of life elsewhere in the galaxy. Together, 3I Atlas and C2025 R2 represent two sides of the same cosmic coin. One is a visitor from the interstellar void, bearing the chemical fingerprints of a distant star system. The other is a local wanderer, caught in the dance of the solar system, its dust storm hinting at the turbulent forces that shape cometary evolution. Both comets challenge our understanding of the universe, pushing the boundaries of what we know about the chemistry of space. As we embark on this journey through the lives of these two remarkable comets, we will uncover the scientific mysteries they present and explore the profound implications they hold for our quest to understand the origins of life in the cosmos. To truly appreciate the significance of 3I Atlas and C2025 R2, we must delve into the intricate science that defines these comets. Each represents a unique chapter in the story of the universe, with their origins, compositions, and behaviors offering clues about the processes that shape not only our solar system but also the wider cosmos. Let's begin with 3I Atlas, a comet that has captured the imagination of astronomers worldwide due to its interstellar origins and unusual chemical makeup. 3I Atlas is the third confirmed interstellar object to have visited our solar system, and its journey is nothing short of extraordinary. Discovered on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System, ATLAS in Chile, This comet entered our cosmic neighborhood at a staggering speed of 58 kilometers per second, 36 mimoi, relative to the Sun. Its hyperbolic trajectory, a path that curves sharply and escapes the Sun's gravitational pull, immediately signaled its extraterrestrial origin. Unlike the two previous interstellar visitors, 1I Oumuamua and 2I Borisov, 3I Atlas is not just a passive traveler. It is an active comet, complete with a glowing coma and a faint tail. This activity is driven by the Sun's heat, which sublimates the comet's ices, releasing gases and dust into space. The most striking feature of 3I Atlas is its chemical composition, which defies expectations. Observations by the James Webb Space Telescope (JWST) and the Hubble Space Telescope have revealed a surprising abundance of carbon dioxide in its coma, a substance that is relatively rare in solar system comets. This finding suggests that 3I Atlas may have formed in a colder, more distant region of its parent star system, where carbon dioxide could freeze and accumulate. Additionally, the comet emits trace amounts of water ice, water vapor, carbon monoxide, and carbonyl sulfide, compounds commonly associated with cometary activity in our own solar system. However, the most intriguing discovery is the detection of cyanide gas and atomic nickel vapor in its coma, substances that are rarely observed in such quantities. These elements hint at a complex and dynamic chemical environment, possibly influenced by the unique conditions of the star system from which 3I Atlas originated. The age of 3I Atlas adds another layer of mystery. Studies of its trajectory and velocity indicate that it could be as old as 7 to 14 billion years, making it potentially older than our solar system, which is approximately 4.6 billion years old. This ancient age suggests that 3I Atlas may have originated from the Milky Way's thick disk, a region populated by older stars with lower metallicity. The thick disk is a relic of the galaxy's early history, and the presence of a comet from this region provides a rare opportunity to study the chemical and physical conditions of the Milky Way's distant past. The journey of 3I Atlas is also a testament to the vast scale of the cosmos. It traveled over 3,750 astronomical units, a U equivalent to 551 billion kilometers, 349 billion miles, before reaching our solar system. To put this into perspective, the distance from the Sun to Neptune is just 30 AU, meaning 3I Atlas traversed the equivalent of 105 Neptunian orbits to arrive here. Its closest approach to the Sun occurred on October 29, 2025, at a distance of 1.36 AU, placing it between the orbits of Earth and Mars. Despite its proximity, 3I Atlas will never pose a threat to our planet, as its trajectory ensures it remains at least 1.8 AU away from Earth at all times. The study of 3I Atlas is not just an exercise in observation, it is a window into the chemistry of alien star systems. The presence of cyanide and nickel in its coma raises questions about the types of reactions that occur in interstellar space and the conditions necessary for the formation of complex molecules. These findings could provide insights into the universality of chemical processes and the potential for life to emerge in diverse environments. For instance, cyanide is a precursor to amino acids, the building blocks of proteins, and its presence in 3I Atlas suggests that the ingredients for life may be more widespread in the galaxy than previously thought. While 3I Atlas is a visitor from the stars, C2025 R2 is a product of our own cosmic backyard, discovered by Vladimir Bezugli on September 11th, 2025, using images from the Solar and Heliospheric Observatory (SWAN) instrument. This comet has captivated astronomers with its sudden and dramatic brightening. Initially observed at a magnitude of 7.4, C2025 R2 rapidly evolved into a prominent object in the night sky, reaching an apparent magnitude of 6.2 by September 16. Its tail, stretching over 2 degrees in length, is a testament to the forces at play as it interacts with the Sun's radiation and solar wind. The behavior of C2025 R2 is particularly intriguing because of its potential to disintegrate. Comets are fragile bodies composed of ice, dust, and rocky material, and their survival depends on the balance between the sun's heat and their structural integrity. In the case of C2025 R2, its rapid brightening and the presence of a massive dust storm suggest that it may be undergoing a catastrophic fragmentation event. This process, often referred to as a cometary outburst, occurs when the sun's energy causes volatile ices to sublimate violently, releasing large amounts of gas and dust. The resulting pressure can destabilize the comet's nucleus, leading to the ejection of fragments or the complete disintegration of the body. The dust storm observed in C2025 R2 is a key feature that sets it apart from many other comets. While dust is a common component of cometary activity, the sheer volume and intensity of the storm in C2025 R2 indicate a significant internal disruption. This phenomenon is not fully understood, but it is believed to be linked to the comet's internal structure and the distribution of volatile materials. The dust storm may also play a role in the formation of meteor showers, as the ejected particles could eventually intersect with Earth's orbit, creating a cascade of meteors in the sky. The chemical composition of C2025 R2 is another area of interest. While detailed spectroscopic analyses are still ongoing, preliminary observations suggest that the comet contains a mix of silicates, organic compounds, and possibly water ice. These materials are critical for understanding the processes that lead to the formation of planets and the distribution of organic molecules in the solar system. The presence of organic compounds in C2025 R2 aligns with the hypothesis that comets may have played a role in delivering the building blocks of life to Earth and other planets. The trajectory of C2025 R2 is equally fascinating. It reached perihelion, the closest point to the Sun, on September 12, 2025, at a distance of 0.5 AU. This proximity to the Sun subjected the comet to extreme temperatures, triggering the sublimation of its ices and the release of its dust storm. The comet's closest approach to Earth occurred on October 19, 2025, at a distance of 0.26 AU, bringing it within 39 million kilometers, 24 million miles of our planet. This close encounter offered an unparalleled opportunity for observation, allowing astronomers to study the comet's structure and composition in unprecedented detail. Despite its dramatic activity, the long-term fate of C2025 R2 remains uncertain. The comet's orbital period is estimated to range from 1,400 to 20,000 years, depending on the accuracy of its aphelion, the furthest point from the Sun calculations. If the comet survives its close encounter with the Sun, it may return to the outer solar system, where it could remain undisturbed for millennia. However, the likelihood of its disintegration is high, as the stresses induced by solar heating often prove too great for cometary nuclei to withstand. Both 3I Atlas and C2025 R2 serve as natural laboratories for studying the chemistry of the universe. Their unique characteristics highlight the diversity of cometary bodies and the processes that shape them. 3I Atlas, with its interstellar origins and exotic chemical composition, offers insights into the conditions of distant star systems and the potential for universal chemical processes. Meanwhile, C2025 R2 provides a closer look at the mechanisms that govern cometary activity within our own solar system, shedding light on the role of comets in the distribution of organic material and the formation of planetary systems. These comets also underscore the importance of interdisciplinary research in astronomy. The study of comets requires expertise in physics, chemistry, and planetary science, as well as advanced technologies such as spectroscopy and imaging. Instruments like the JWST and Hubble have revolutionized our ability to analyze the chemical composition of comets, allowing us to detect even the faintest traces of complex molecules. Ground-based observatories and space telescopes work in tandem to track the movements of comets and monitor their transformations, providing a wealth of data for scientists to analyze. In summary, the science behind 3I Atlas and C2025 R2 is a testament to the complexity and beauty of the cosmos. These comets are not just fleeting visitors, they are dynamic entities that carry the imprints of their origins and the secrets of the universe. By studying them, we gain a deeper understanding of the processes that shape the solar system and the galaxy beyond. bringing us one step closer to unraveling the mysteries of life's origins. The study of 3I Atlas and C2025 R2 extends far beyond their individual characteristics, offering profound insights into the broader implications of cometary chemistry for the origins of life and the interconnectedness of the universe. These comets serve as cosmic messengers, carrying the imprints of their respective star systems and providing clues about the chemical processes that govern the formation of planets, the distribution of organic molecules, and the potential for life to exist elsewhere in the galaxy. As we delve deeper into their mysteries, we uncover not only the secrets of their origins, but also the possibility that the building blocks of life may be more widespread and perhaps even universal than previously imagined. One of the most compelling aspects of 3I Atlas is its interstellar origin and the implications it holds for the chemistry of alien star systems. The detection of cyanide and nickel in its coma is particularly significant, as these elements are not typically found in such abundance in solar system comets. Cyanide, a compound composed of carbon and nitrogen, is a precursor to amino acids, the fundamental building blocks of proteins. The presence of cyanide in 3I Atlas suggests that the conditions necessary for the formation of complex organic molecules may be common in interstellar space, even in star systems vastly different from our own. This raises the tantalizing possibility that the ingredients for life are not unique to Earth, but may be distributed throughout the galaxy, carried by comets like 3I Atlas on their endless journeys. Moreover, the age of 3I Atlas, estimated to be between 7 and 14 billion years, provides a glimpse into the early history of the Milky Way. If the comet indeed originated from the galaxy's thick disk, a region populated by ancient stars, it may have formed in an environment with different chemical abundances than our own solar system. The thick disk is characterized by lower metallicity, meaning that stars in this region contain fewer elements heavier than helium compared to younger stars in the thin disk. This difference in composition could influence the types of ices and organic molecules that form in such regions, potentially leading to variations in the chemical makeup of comets from different parts of the galaxy. By studying 3I Atlas, scientists may gain valuable insights into the chemical evolution of the Milky Way and the conditions that existed in its early stages. The presence of carbon dioxide in 3I Atlas's coma also has important implications for our understanding of cometary activity. Carbon dioxide is a volatile compound that sublimates at relatively low temperatures, making it a key component in the formation of cometary atmospheres. In the solar system, carbon dioxide is primarily associated with comets from the outer reaches, such as those originating from the Kuiper Belt and the Oort cloud. However, the fact that 3I Atlas contains such a high concentration of carbon dioxide suggests that its parent star system may have undergone a different evolutionary history. Perhaps the temperature conditions in its home system allowed for the accumulation of carbon dioxide-rich ices, or maybe the comet formed in a colder region where such volatiles could condense and remain stable over long timescales. Either way, the study of 3I Atlas's chemistry opens new avenues for exploring the diversity of cometary compositions and the factors that shape their formation. In contrast to 3I Atlas, C2025 R2 represents a more familiar type of comet, one that originates from within our solar system. However, its dramatic brightening and dust storm provide a unique opportunity to study the processes that drive cometary activity and the role of comets in the distribution of organic material throughout the cosmos. The dust storm observed in C2025 R2 is particularly intriguing, as it suggests a significant internal disruption of the comet's nucleus. Such disruptions are not uncommon in comets, especially when they pass close to the Sun. But the scale and intensity of the event in C2025 R2 raise questions about the underlying mechanisms at play. Was the comet simply responding to the increased solar heating, or was there a more complex process at work, such as the release of trapped volatiles, or the fracturing of its icy interior? Understanding these processes is essential for predicting the behavior of comets and assessing the risks they may pose to planetary bodies, including Earth. The dust storm in C2025 R2 also has implications for the distribution of organic molecules in the solar system. Dust particles released during cometary outbursts can travel vast distances, potentially carrying complex organic compounds across the solar system. These particles may eventually settle on planets or moons, contributing to the inventory of organic material available for prebiotic chemistry. In this sense, comets like C2025 R2 may act as cosmic couriers, transporting the raw materials for life to different parts of the solar system. The study of such cometary events is therefore crucial for understanding the role of comets in the emergence of life and the potential for habitable environments beyond Earth. Furthermore, the potential connection between C2025 R2 and future meteor showers highlights the dynamic interplay between comets and planetary bodies. As the dust storm from C2025 R2 expands, some of the ejected particles may eventually intersect with Earth's orbit, creating a meteor shower when they enter the atmosphere. Meteor showers are not just spectacular displays in the night sky. They also provide valuable information about the composition of cometary dust and the history of the solar system. By analyzing the chemical makeup of meteorites and the debris left behind by meteor showers, scientists can reconstruct the origins of these particles and trace their journey through space. The study of C2025 R2's dust storm may therefore contribute to our understanding of how cometary material is dispersed and how it influences the evolution of planetary systems. In addition to their scientific significance, 3I Atlas and C2025 R2 also raise philosophical questions about the interconnectedness of the universe. The fact that these comets originate from different parts of the cosmos, 3I Atlas from the depths of interstellar space and C2025 R2 from the outer reaches of our solar system, demonstrates that the universe is a web of relationships, where even the most distant objects can leave their mark on planetary systems. The study of comets reminds us that we are not isolated in the universe. Rather, we are part of a vast and intricate network of celestial bodies, each carrying the legacy of its origins and the potential to shape the future. Ultimately, the exploration of 3I Atlas and C2025 R2 underscores the importance of comets in our quest to understand the origins of life and the chemistry of the cosmos. These comets are more than just transient visitors. They are cosmic archives, preserving the chemical imprints of their star systems and offering a glimpse into the processes that govern the formation of planets and the distribution of organic material. As we continue to study these enigmatic objects, we may uncover answers to some of the most profound questions about our place in the universe and the potential for life beyond Earth. As we conclude this journey through the lives of 3I Atlas and C2025 R2, it becomes clear that these comets are more than just distant wanderers. They are cosmic bridges connecting us to the vast unknown. In the quiet hum of the universe, comets whisper the stories of their origins, carrying the imprints of star systems we've never seen and processes we are only beginning to understand. Whether it's the interstellar traveler 3I Atlas, with its cyanide clouds and ancient origins, or the dusty dynamo C2025 R2, whose stormy tail dances with the sun's fury, these comets remind us of the universe's boundless complexity and the shared threads that weave together the fabric of existence. The study of comets like these has always pushed the boundaries of human knowledge, challenging our assumptions and expanding our understanding of the cosmos. 3I Atlas, for instance, is not merely a visitor from the stars. It is a time capsule from a forgotten corner of the Milky Way, a relic of a bygone era that predates the solar system itself. Its journey across the galaxy and its arrival in our cosmic neighborhood invite us to contemplate the vastness of time and space. How many other interstellar travelers have passed through the solar system unnoticed? How many more await discovery, carrying the secrets of distant stars and the chemistry of alien worlds? The mere existence of 3I Atlas suggests that the universe is teeming with possibilities, and our role as explorers is only just beginning. Similarly, C2025 R2 serves as a reminder of the dynamic and ever-changing nature of the cosmos. Its sudden brightening and dramatic dust storm are testaments to the fragility of comets and the powerful forces that shape their fates. Yet, even in their instability, comets like C2025 R2 play a vital role in the grand tapestry of the universe. They are not just passive objects, they are active participants in the cosmic cycle, scattering dust and organic molecules across the solar system and potentially seeding the conditions for life. The idea that comets may have delivered the building blocks of life to Earth or to other planets is a humbling realization, one that connects us to the universe in ways we are only beginning to grasp. Beyond their scientific significance, comets like 3I Atlas and C2025 R2 evoke a profound sense of wonder. They are tangible reminders of our smallness in the grand scheme of the cosmos and the infinite possibilities that lie beyond our current understanding. The sight of a comet streaking across the night sky has inspired poets, philosophers, and scientists for centuries, igniting imaginations and fueling the desire to explore the unknown. In the case of 3I Atlas and C2025 R2, this sense of wonder is amplified by their unique characteristics and the questions they pose. What other mysteries do they hold? What other secrets lie hidden in the icy hearts of comets yet to be discovered? As we reflect on the significance of these comets, we are reminded of the interconnectedness of all things. The atoms that make up our bodies, the stars that light up the night sky, and the comets that traverse the heavens are all part of the same cosmic story. A story written in the language of chemistry and physics, spanning billions of years and countless star systems. The study of comets is not just an academic pursuit, it is a journey into the heart of existence, a quest to understand our place in the universe and the forces that have shaped it. In the end, the stories of 3I Atlas and C2025 R2 are not just about comets, they are about us. They are about our insatiable curiosity, our drive to explore, and our relentless pursuit of knowledge. They remind us that the universe is full of mysteries waiting to be unraveled, and that the answers we seek may lie in the most unexpected places. As we continue to study these comets and others like them, we are not just observing the cosmos, we are participating in its unfolding story, adding our own chapter to the timeless tale of exploration and discovery. So the next time you gaze up at the night sky, remember that you are looking at a canvas painted with the light of distant stars and the trails of comets that have traveled across the galaxy. Each comet is a reminder that the universe is alive with motion, change, and possibility. And perhaps in the icy hearts of these celestial wanderers, we will find the key to unlocking the greatest mystery of all, the origins of life itself.